Telltale of COVID-19 apocalypse. It was 31st December 2019, the New Year Eve. WHO China office was informed of a pneumonia-like outbreak with 40-odd patients from Wuhan city who complained of fever, respiratory distress, cough, fatigue, and they were exposed to Wuhan seafood market, which primarily traded in live animals like bats and pangolins. On 12 January, China shared the genomic sequence of this virus as beta coronavirus. On 24 Jan, Lancet published its first paper stating the clinical manifestations of these patients. They had high cytokine chemokine expression, lymphopenia with a reduced CD4 CD8 T cell counts, high D dimer. It's a degradation product of fibrin, which is actually a readout of hypercoagulation, the hallmark of severe COVID patients. The patients also had ground glass opacities accounting for pleural effusion and ARDS, which leads to ARDS. The patients also reported of comorbid conditions like diabetes, hypertension, cardiovascular diseases. On 29 Jan, another paper came out stating the similarity of the sequence with a bat-derived virus, and it's phylogenetically distant to SARS and MARS, though they have similar manifestations. Now, bats are known to asymptotically harbor Ebola, Nipah, rabies, SARS. Now, what is so special about these bats? So, bats have a dampened inflammatory response. So, the sting pathway is downregulated, the JNF alpha pathway is downregulated, and also NLRP3 pathway is downregulated. Only interferon alpha is constitutively expressed. So, perhaps that's the reason how actually they take care of this virus by harboring it. It was early June, it was restricted to China itself, but by March end, it spread throughout the world. Why it is so infectious? The spike protein of the CoV2 binds 10 to 20 times stronger than the spike protein of coronavirus to the AC2 receptor, and the presence of furin recognition motif in the spike protein makes it more infectious. The course is in the primarily 80% of the population who are RT-PCR positive for SARS-CoV-2, they are asymptomatic, but the remaining 20, the severe and the critical, they need hospital intervention, the stage 2 and stage 3. Pathophysiology. So for the mild and moderate, it's the type 1 interferon which takes care with a low viral load and with the lymphocyte is in normal range, but with the inflammatory cytokines with not much of activation. But in the severe patients, it is actually the inflammatory cytokines which actually ramps up and causes the damage to the system, with the lymphocyte going down, and also the type 1 interferon goes down. So perhaps that's the reason which accounts for the exacerbated pathophysiologies. So it's actually the type 1 and the ISGs which are known to be suppressed. As we see here, if we move from severe to critical, the interferon production goes down, and also for the ISGs. So actually the virus, they outsmart the host system by suppressing the antiviral system of host, type 1 interferon and the ISGs. So they do it by the use of the non-structured protein 1. As we see here, when you are transfecting this NSP1, the luciferase translation is being inhibited, but the mutant one is not being inhibited. As the severity of the disease progresses, there is a hyperstimulation of the proliferase cytokines. As we see that TNF alpha, IL-6, IL-1, CXC, CCLs, chemokines are all activated in the severe form. So it's actually interferon lambda which disrupts the epithelial barrier. When poly-IC-TLR3 agonist is instilled into the lungs, there is an increase in the protein in the bulk fluid. And interferon lambda receptor knockout mice, they are well protected in comparison to the wild type. The P53 pathway was also activated in the wild type in comparison to the IFNA knockout. P53 is not only known for its apoptotic role, but is also known for its necrotic role. So in an artery occlusion method, so there is a blockage of the blood flow, and that disrupts the mitochondrial function. The mitochondrial dehydrogenase, it actually converts one of the dye into a red, and for that reason the red coloration happens. So here we see in the wild type range, so there is an infraction, so the mitochondria is dysfunctional. But in the P53 heterozygous, it's well protected, and equally for cyclosporin, which actually is an inhibitor of mitochondrial permeation pore. So there is also a good amount of protection. So this is very similar to the severe COVID patients. In severe COVID, there is also hypoxia and there is a fibrin deposition in the capillaries, which blocks the arteries and the capillaries. So there might be a necrosis, and this is well documented. In COVID lungs, there are necrosis events. This is the pneumocytes, which is reflected by arrows. And in COVID lungs, there are 9 times more amount of microthrombi, which is being formed in the lungs than the H1N1, typically ARDS lungs. So this microthrombi in the capillaries, they block the oxygenated blood movement and restrict the gaseous exchange, which lead to ARDS. Now the dead cells can also initiate inflammation in an IL-1 dependent, IL-1 alpha dependent fashion. So if you add neutralizing antibody to IL-1 alpha, so there is a decrease in neutrophil influx and also inflammation, but not with neutralizing IL-1 beta antibody. So also the IL-1 receptor knockout mice showed a much decreased inflammation. IL-1 alpha also plays a very critical role in blood coagulation. When the pro-IL-1 alpha P33 was being incubated with thrombin, it actually caused the production of IL-6, but in presence of the neutralizing antibody, it blocked the expression of IL-6, and the active IL-1 P18 was found to be present in ARDS. So it has a very important biological role. In IL-1 alpha is actually being secreted out by only necrotic cells. So it actually, when it's secreted out, it transits the downstream signaling by attaching to IL-1 receptor and forming the CXCL, CXCL2, which are the chemokines which attract further the neutrophils and macrophages to the lungs and exacerbates the pathophysiology. It can also work in a paracrine fashion by binding to IL-1 receptor and forming IL-1 beta, which actually amplifies the whole system. It's hierarchically, it's actually perhaps IL-1, the first cytokine which is being secreted in a PP3 and interferon lambda dependent fashion. Thereafter, IL-1 alpha can further activate IL-1 beta, IL-6, IL-17, and the chemokines. IL-17 is also a very important role, plays a very important role in the lung pathology. IL-17 receptor knockout mice have shown to have reduced inflammation, and more so IL-17 is being controlled by IL-1 beta. So IL-1 actually looks like the master regulator. Therapeutic interventions, as long as we don't have a vaccine, so let's take on the repurposing. For the asymptomatic antivirals, uh, interferon beta and remdesivir. For severe and critical, perhaps a combinatorial approach of anti-inflammatory and antivirals and anticoagulants would be a good one. Anakinra has shown much promise, and blocking gasdermines and caspase, which works upstream in the inflammasome pathway, can be good targets too. And other cytokine blockers like TNF alpha and IL-6. So to wind up, the suppression of the interferons coupled with hyperstimulation lead to severity of the disease, and IL-1 can be the master regulator of the inflammatory cascade. I gratefully acknowledge the insightful discussion with Dr. Physical and Dr. Golenbach, and I'm grateful to Dr. Tomar for the video edits. Thank you so much.